Okay, so I think we should start now. Today we would be doing experiment number 3, tutorial 3. Okay, is my voice clear? First of all, tell me that. Any one of you? Is my voice clear? Any one of you can post in chat box. Everything okay? Okay, fine. Okay, so let me tell you what that experiment is. First of all, see in our list of tutorials, we are going to do this third experiment today. Okay, it is basically about COCOMO model. COCOMO stands for constructive cost model. So we would be studying first of all constructive cost model, because this whole is nothing but a numerical. Okay, so this is a numerical given to you which you need to solve using COCOMO. For that, you must first understand the concept of COCOMO. It is a model which is used to estimate cost. First, we will study the concept, the method involved in COCOMO, and then we can do this one, this numerical. Okay, so let us start with COCOMO. Okay, see, uh, there are few things which are involved when you are talking about developing a software. There is stage, there are many stages before you have the final product as the software. Okay, so for that, the first one is you gather the requirement from the customer. I'm saying, because if I suppose that you are the service provider who is sitting in this end to deliver that software to the customer who is sitting on the other end, or the user, then customer requirement, and then after analyzing those requirements, we will make the various diagrams, or you can say SRS. In SRS only we study the types of diagrams till now in experiment number 2, and then after analyzing that SRS, you will start developing the software. So how it works is like something like this. A process. This process can be summarized like this. So when you talk about the steps before developing a software, after you have analyzed the requirements and made your SRS, now after you have an idea of what your software is going to be like, what do your customer expect from that software, after that, what you need to do, you need to have estimation of things. Which things I'm saying? You need to have estimation of the effort you need to put to make this software, the time you need to make this software, and the cost of the software. Okay, and all these can be determined on the basis of size of the software. So first thing which comes is the size. So if you know what can be the size, what is the expected size of your software, because you have not started coding till now. At this stage, you have not started coding. So what you can do, you can take a reference from the pre-existing software, and then you can have an idea. For that idea, they are using the word estimation. So you can have an estimation of the size, and on the basis of that estimated size of the software, you can calculate or you can estimate efforts which will be involved, time which you need to give to develop that project, and the cost of the project. Okay, the first thing comes is size, the topic under which your COCOMO model comes. For that, you need to have this prerequisite knowledge of all these things, because COCOMO is constructive cost model. So the cost involved in constructing the model or the software, that is what it talks about, or that is what it calculates. So for that, what you need to do, you need to have an idea of all these things, because everything is interrelated. Now we are talking about the estimation and scheduling of software projects. Scheduling means time. कैसे शेड्यूल करना है, कैसे स्केड्यूल करना है कि you have an estimation that इतने months में this project will be completed. For that, you need to have estimation and proper scheduling of the software project which you are making. The first term, which is software sizing. Software sizing can also be termed as software size estimation. So this itself explains that what it will do. It will estimate the size of the software. Okay. So estimating the size of the software is software sizing. Like you have the unit of measurement as weight for the body or for a material, in the same way for softwares we have size as the unit of measurement. If you want to talk about the unit of measurement for a material, that material can be anything. We say that weight is the unit of measurement. And if you talk about the software, then its size is the unit of measurement to judge that software. Okay. Now there is a term which is called productivity. Productivity of a company, productivity of an employee, productivity of the software, anything. So what is this productivity? To understand productivity, you need to have the concept of effort and size clear in your mind. What is effort and what is size? Because these two are different terms. Okay, size is basically what would be the size of your project. Size is basically how long, how short, how much complicated is going to be your project. And effort is how much hard work you need to put to make that software. So these two things together will tell about the productivity of the software. Okay, so the relation between size of the software and effort required to produce the software, that is called productivity. If you need to judge the productivity, you need to have estimation of the size and estimation of the effort. Okay, so sometimes they may ask you what is the productivity. So to calculate that, you should use effort and size. Now there are various techniques which are available using which we can estimate the size. First of all, we will talk about the basic concept which I told you, which is the basis for everything, that is size. So, for estimation of size, for judging the size or to predict the size of the software, there are four techniques. Before studying these four techniques, you should know that why do we need to predict the size. I have told you already, although predicting the size or estimating the size will help the project manager to further predict the effort and time which will be needed to build the project. This one, see, here you can see this clearly what I've told you, that to predict effort and time. If you want to predict how much effort we need to put, how much time we need to give, for these two, we need to have an estimation of the size of the project. That is why estimating size is important and it should be the first step. The techniques which are used to estimate size are: first is lines of code, second is number of entities, third is total number of processes in DFD, and fourth one is function point analysis or simply function point. Lines of code, number of entities, total number of process and function point. These are the four techniques which are used. Let us study each technique in detail. to estimate size of the project. Okay. Now see, the first technique is lines of code. Lines of code is also abbreviated as LOC. So LOC stands for lines of code. Now, as the name is suggesting, what this method will do, what this technique will do, it will count the number of lines of code in a software. Now, a question must come in your mind that we have not started coding yet. Then how can we count the lines of code? So for that, what you need to do, what the technique that is involved in estimating or in counting these lines of code is that they take a reference. See, a similar kind of software would have been existing already. There must be a similar kind of software. So what it will do, it will take that software, it will add its feature and an estimate of how many lines of code will this feature use. So using this, it will do what? It will predict. It will not be an exact count of the lines of code. It will just predict how many lines of code can be there, and based on that, it will deliver the count of the lines of code that your project will have. Okay, so it is just a estimate, not the exact count. The units which can be used when you talk about when you talk about in terms of lines of code, the units alternatively which can be used are, if there are thousands of lines of code, use kilo lines of code, that is KLOC. If NLOC is mentioned, that means all the non-comment, excluding the comment, other lines of codes have been counted. If you talk about KDSI, K stands for kilo, D stands for delivered, S stands for source instruction. So all the thousands of delivered source instruction will be counted if you use this unit. So whatever is your need, you can use that particular unit. Okay, and usually because lines of codes are thousands and more than that in number, so usually the unit used is this one, kilo lines of code. Okay, now there are certain advantages and disadvantages of this technique using lines of code for size estimation. The first advantage is that the most important one, that COCOMO uses lines of code. Our constructive cost model uses this lines of code as the technique to to estimate the size of the software. So this is the most important point, that whichever technique you are using, ultimately you have to convert it into lines of code, that is LOC, if you want to work with COCOMO model. Then there are certain disadvantages also, that programming languages, if programming languages differ, then lines of code that count can also differ. Okay, so different programming languages contain different number of lines. If you change it, if you change the platform, then obviously the count will change. So like that, there are other disadvantages also, but the main ones are this. Okay, this was your first technique to estimate size. Second is the number of entities in ER diagram. You have drawn ER diagram. Already you know what is ER diagram. There are entities, attributes, and relationship between them. So if you count the number of entities in ER diagram, then those entities will tell you about the estimated size. Okay, so on number of entity depends on the size of the project. So if there are more number of entities, that means project size is big. Otherwise it can be moderate or small. Okay, why is it so? Because there more entities are more entities need more classes or structure, thus leading to more code. Each entity, if you code as a different structure or in a different class, then multiple classes will be involved, which will increase the size of the code. That is why, judging the entities, the count of entities, you can have an idea of what can be the size of the code. Okay. Now its advantage is that we can determine the size estimation at the initial phase or the starting phase of planning, because we make ER diagram in the initial phase or the analysis phase only. Okay, and the disadvantage is that there is no fixed standard. Some entities contribute more project size than other. So we cannot define a standard to use this technique. That is the disadvantage. This is how you can estimate size using entities in the ER diagram. Third one is using number of processes in DFD. DFD is your data flow diagram. Processes are represented using bubbles or circles. Okay, so if there are many sub-processes, then your software is obviously complex. Like I've told you, at level 0 there is only one process. At level 0 there is only one process. So complexity is not much. At level 1 there can be more than one process and sub-process. At level 2 even it increases even more. So like that, depending upon how many number of process, the complexity will increase, and with increase in complexity the size will also. Okay, so if you have a count of the total number of processes which are involved in DFD, so you can have an estimation of the size of the project in the same way like you estimated the entities. But like every other technique, there are certain advantages and disadvantages linked with it. What are the advantages of using TFD for size estimation? The advantage is that it is independent of programming language, because the count of process do not depend upon programming language. So for every any kind of language, your DFD made will be same. Okay, and the disadvantage is that all the software projects are not required to construct DFD. It is not necessary to construct DFD every time for every kind of project. So if you don't have DFD for a particular project, then how will you estimate size? So you cannot generalize this technique. Okay, so these are the few advantages and disadvantages of third type of technique, that is your number of processes in DFD. Now comes the fourth type of technique, which is important, I would say, apart from lines of code. This technique is one of the most frequently used techniques. That is function point analysis. You can write its short form as FPA. I hope everyone is understanding this concept, what I'm explaining. If there are any doubts, you can ask me. Okay. Okay, I will proceed further. See, this is the fourth and the last type of technique for software size estimation. What we do in this technique is we will find out the number and type of functions. What is the name of the technique? Function point analysis. So what it does, it finds a number and type of function which is supported by the software, and this will be used to find the function point count. In function point analysis, we will calculate function point count on the basis of the number and type of functions available or supported by the software. For doing so, there are various steps, and those 5 steps are listed here. To calculate function point count, that is FPC. Those 5 steps are, see, first what you need to do, you need to count the number of functions of each proposed type. The type we were talking about here, all those types of function we need to count. Then second is computing the unadjusted function point. You need to calculate, you need to compute a factor which is called unadjusted function point. I will tell you how to do it. Then comes finding out or calculating TDI, that is total degree of influence. Then comes calculating or computing VAF, that is value adjustment factor. And then comes finally calculating the function point count. The first, you need to know the types and count of the function, then calculate UFP, then TDI, then VAF, and then finally FP. Now let us see how we need to calculate all these factors. The first step was counting the number of functions of each type. Okay. Now, what is this type? Why we are using this word type again and again? So there are all the functions which are involved within the system or the software. They can be categorized under five types. That is external input, external output, external inquiries, internal files, and external interface files. The functions we have, every function will belong to one of the category. Okay. What do you mean by this category external input? Which functions can be included here? So all the functions which are related to data entering the system from external to internal. So like that. All the data which is entering the system, that will be external input. Opposite to that is external output. All the data which is exiting the system will be external output. External inquiry is simply asking a question, like you inquire about things in normal life. So in the same way, inquiry is simply extracting the data or retrieving the data. So external inquiry will lead to data retrieval, but it won't cause any change, because simply asking a question will not change the state of the system. Okay. Then internal files are all the files which are maintained within the system. All the logical files which are maintained within the system are categorized as internal files, but these files do not contain the log. Okay, so I think call got disconnected. Can anyone tell me from where should I start again? Because I didn't notice when did the call got disconnected. Should I continue or should I start with some topic which was left? Because I didn't get any notification when did the call get disconnected. If no one will tell me, then I will continue where I was explaining that part only. Because I think I can continue with where I was explaining because no one is replying. So I will take it as you have heard everything and you all are understanding everything. Okay, so this is how we will calculate unadjusted function point by multiplying the weight factor with the count of each function point. Then comes the third step, that is finding the total degree of influence, TDI. To find the TDI, total degree of influence, you need to use 14 general characteristics. What are these 14 general characteristics? So for that, there is a list given over here. The 14 general characteristics. Data communication, distributed data processing, performance, heavily used configuration, transaction rate, online data entry, end user efficiency, online update, complex processing, reusability, installation ease, operational ease, multiple sites and facilitate change. So these 14 characteristics are used. Each of them will have a count, okay, and they will be evaluated on a scale of 0 to 5. So suppose if data communication is given 2, then we will consider it as 2. Okay, we will consider this value. Suppose this is given 1. So like that, all the 14 characteristics will be evaluated between 0 to 5. The scale will be 0 to 5, and then what we can do, we will sum up all these numbers and we will calculate TDI. Okay, so summing up all these will give us the value of TDI, and the value of TDI must lie between 0 to 70. Like these characteristics are judged on the evaluated on the scale of 0 to 5. Similarly, TDI's value, when we sum up all these characteristics, that must be between 0 to 70. Okay, I just hope that everything is okay now, because before this, just that call got disconnected and I didn't know. Okay, so this was your third step. Then in fourth step, what we need to do, we need to calculate VAF, that is value adjustment factor. To calculate value adjustment factor, the formula used is this, that is TDI, which we calculated in step 3 into zero point 0.01 plus 0.65. So simply put the value here and you calculate VAF, nothing more than that. And finally, to conclude, to calculate FPC, that is function point count, you need to use this formula. That is the value obtained in step 2 multiplied by value obtained in step 4. Okay, unadjusted function point should be multiplied with value adjustment factor to get your FPC, that is function point count. So this is how you use this technique to calculate to estimate the size of the software using function point analysis. Now, like others, there are some advantages and disadvantages. Advantage is that It can be used in early stage of the project planning when it is independent of programming language. And the disadvantage is that the major disadvantage that although we can use it in COCOMO, but ultimately we have to convert it into lines of code to be used directly in COCOMO. Okay? Because COCOMO accepts only lines of code as software size estimation technique. So these were the various techniques to estimate the size of the software. Okay? Now comes after estimating size, estimation of cost and effort. Okay, so cost is what? Cost is defined as a financial spend that is done on the effort to develop. So all the money that has been spent on the effort which is put to develop the product and to test the product. Okay, so cost will be a factor based on the effort which we are giving, which we are putting to develop the software. Now, for cost estimation, there are three kinds of model. There are various techniques which can be used for cost estimation. Those three techniques are empirical estimation technique, heuristic technique, and analytical technique. What is empirical estimation technique? Empirical estimation technique basically uses a formula to estimate the cost. Okay, so it uses a formula. See, it is written over here. Empirical estimation derives a formula that are used for predicting the data required and essential part of the software project plan. Okay, and the formula which it will derive, it will use the size of the software to estimate the effort. Okay, so to that formula will be based on size and it will derive the effort which will tell us about the cost. So this is how empirical technique works. Heuristic technique is heuristic word means to discover. To discover is to invent or to find something new. So to discover is here in heuristic technique what will be done, these techniques are flexible, they depend upon the system. So if the system is a different one, we will not use the authentic like empirical estimation technique using a formula to find the cost. What it will do, it will be flexible and it will discover the way to find the cost depending upon the system, and the results obtained will be optimal, that is more efficient in comparison to other techniques. So the most efficient one you can say is heuristic, and heuristic technique was given by COCOMO model. It was a part of COCOMO model. Okay, so you can see here that in heuristic it is written that it is a flexible and simple for taking quick decision through shortcuts, and the decision makes they are required to be offered. This popular technique is given by COCOMO. Okay, so all these points are all mentioned. Then comes analytical estimation technique. So analytical estimation technique, that is your last type of technique, it is based on assumptions. Okay, so it will make certain assumptions, and based on that assumption it will calculate the cost. See, if you want to know the steps which are involved in analytical techniques, those are: firstly we will divide the task into subtasks or the components into subcomponents. Then what we will do, for each of the component, if the time is given, then it's okay that how much time each component will take to be developed. Otherwise what we will do, we will take a reference of similar kind of project, and then we will have an assumption that these are new components will take this much time. So on that basis, if following this technique, your analytical estimation can be done. Okay, so the three techniques differ like this: that empirical is based on formula, heuristic is to discover and it will give the most optimal result, and analytical is making assumptions so that we can guess the cost involved with the system. These three techniques work like that. Okay. Now see, finally after understanding how to calculate or what is effort, what is time, and what is size when we talk about project estimation. Now, finally comes a model which we should understand, that is COCOMO. Constructive, CO stands for constructive, another CO stands for cost, and this is model. So it will estimate. How does it estimate the cost? Because in the name itself it is saying that it will estimate the cost. How does it estimate cost? So this model predicts the effort and schedule based on the size of the software. The cost is basically how much time you are giving, how much effort you are putting. So that will be determined based on the size. So that is why we needed to add knowledge of everything. Okay, so COCOMO will predict the effort and schedule depending upon the size. Now, COCOMO involves three steps. First step is initial estimation, calculation of initial estimation of the effort using the size, that is kilo or thousands of delivered lines of code. So using this size factor, what COCOMO will do, it will calculate an initial estimate of the effort. Then in second step, there are 15 multiplicative factors, 15 multiplying factors from various attributes. So there are categories of attributes which involve 15 multiplicative factors. Using those, we will do what? We will just determine the effort and time. And finally, what we will do? We will multiply the step 1 results with step 2 to get our result, the final result of the cost of the model or of the software. So in first step, we did initial estimation. In second step, we determined the 15 multiplying factor, and finally we multiplied these factors with the initial estimate, and we will get the effort estimate, the final effort estimate. Let us see how it works. See, the first step was initial estimate. To find the initial estimate of the effort, there is a formula given which is universal formula. Now every modification will be done on this formula. The EI, that is effort, is calculated as multiplication of constant A with the size, that is kilos of delivered lines of code, into another constant, that is B. Okay, so if you want to calculate initial effort, what you will do? You will multiply two constant with the size. Okay, now one thing is there, that there are various types of project. The projects on which we are performing this estimation, those can be of different types or categories. First, depending upon the complexity. See, I will tell you very like in easy language that project can be simple, it can be little complex, or it can be most complicated. So when you say that project is simple, then it is of organic category. When you project say that project is like semi-complex, then it is of semi-detached category. When you say that project is too complicated, then it belongs to the embedded category. Okay, so this is the simplest explanation that projects can be of three types. If you talk about organic, in organic project, the team size will be small and the team members will be experts. So there is going to be no problems. What happened to Parita Ben? Why did you raise your hand? Is there something? Okay. So, organic is a type of project in which there is a small team and all the team members are your experienced person. Like, for example, simple projects like simple business system, simple inventory management system, data processing system, all these belong to this category. Then comes semi-detached category. In semi-detached category, I told you The team size would be moderate, average, and the team members will be mixture of experienced and unexperienced staff. Okay, example of such kind of projects can be developing a new operating system or a new DBMS. So these type of projects will come under semi-detached category. And if you talk about embedded system are strongly coupled to complex hardware. Like using this example, looking at this example, you can understand this clearly. Like air traffic control. So air traffic control is in itself a complicated project involving a complex hardware. So such projects will fall under embedded category. These are the three types of projects which can be there. Okay, organic, semi-detached, and embedded. Now, see, the model, this COCOMO model was given by Bohem, and he's also proposed one thing that COCOMO, see, these types of projects are there. We have seen organic, semi-detached, and embedded. So if we try to apply COCOMO on embedded projects directly, then it is going to be complicated. So that is why for such projects which are too complicated, Bohem suggested that this model can be divided in three stages, that is basic model, then intermediate model, and then detailed model. So basic model will use minimum information to estimate the cost, effort, and cost. It will estimate but using minimum detail. Then more details will be included to make a result even better. You in intermediate model and detailed model will have even more information to calculate the effort. So with each stage, the information or the details are getting increased. Like the name itself is suggesting, basic model will simply calculate the size and effort, cost and effort. Intermediate will use little more detail to estimate cost and effort, and detail will use even more detail. Okay. So if we talk about basic model, what is the formula which is used here in basic model to calculate effort and time? Same formula is there. See, just now I've told you that to calculate effort, the formula was A1 into size, that was kilos of delivered lines of code there, and another constant. Same formula is used here. Constant into size, that is kilo lines of code, into A2, another constant. Here the unit used is person month. The unit of effort is person month. Then this is T dev is the time needed to deliver the code. T dev is for time. So the time which will be needed will be B1, that is a constant. There will be a fixed value into effort. This effort is this one, same. So you will calculate effort here and use it to calculate the time for this. Effort into V2, and because it is time, it will be measured in months. So these are the formula which you can use in your basic COCOMO model to calculate effort and time. Now there is one thing that we know that project can be organic, semi-detached, or embedded. Okay, we have seen these three categories of projects. These three categories of projects are there. So the formula for basic COCOMO for all these types, for basic COCOMO, the formula of effort and time, this generalized formula will have three versions. Why? Because the value of constant will change for each type of. See, the value of constant is changing for each type of project. If we talk about the effort, first we will talk about the effort for each category, each type of project. Then value of A1 is 2.4, value of A2 is 1.05. Value of A1 for semi-detached is 3 and 1.12. For embedded, A1 is 3.6 and A2 is 1.10. So you need to remember these values of constant for each type of project. And kilo lines of code will be given directly, so you can put that value here. Similarly, for the formula of time, B1 and B2 constant were used. So the value of B1 and B2 for the three types of projects is given over here. So you need to remember these values which I have made bold. Okay. So this is how you can calculate effort and time for basic COCOMO model. Okay. See, there is one example given over here that suppose the size of the project is this, and you need to calculate the effort and time for each of the three models, that is organic, semi-detached and embedded. So for these three models, you can simply put the formula. You can simply put the formula value of A1, A2, B1, B2 and calculate effort and time for your basic COCOMO model. Okay, for your basic COCOMO model. If nothing is written, you can take it as basic. But if complications are given, then you have to categorize it as whether you need to use the formula of basic or intermediate or detailed. Okay, so this is how it can be done. There is one more example in which they have taken now this time semi-detached mode. Semi-detached model formula must be used here, and apart from calculating effort and time by directly using the formula, they have also asked for calculating the average staff size. How will you calculate this average staff size? For that, what you can do, because we need what? How many persons are involved. So to calculate person, you can simply divide the effort involved in person. Effort का unit क्या होता है? Person month. तो इसको divide करो with your time, that is month. So what you will get the number of persons involved. So like that you can have an average staff size value. And if you want to calculate the productivity we have seen, it depends upon what? It depends upon the size and effort. So if you divide your size with the effort, then you will get that how many lines of codes can be delivered in persons in how many months. So like that you can derive formula itself if you know the concept. Okay. So productivity can be calculated like that. So for size you divided effort with time. For productivity you divided size with effort. Okay. Now comes intermediate model. What is intermediate model? So intermediate model will use the result from the basic COCOMO, and apart from that, it has 15 cost drivers based on various attributes. What are these? So there are four types of attributes which includes 15 cost drivers. See, the attributes are product attribute, and the cost drivers included in it are these. Then hardware attribute has these cost drivers, and personal attributes have these cost drivers. So like this, if you calculate, the total cost drivers are 15 under four different categories of attributes. So there are certain value or rating assigned to each attribute's mm, cost driver. Okay, so there are certain values assigned to each type of cost driver belonging to a particular attribute category. What you need to do with this is that, see, now there will be a rating, there will be a value provided for each of the cost driver. Now depending upon it, you will do the these all these values will be multiplied to calculate the effort adjustment factor. Effort adjustment factor can be calculated by multiplying all the values given of the relevant cost factor among these. Okay, in that way you will get EAF, and the formula for calculating the effort and time in intermediate COCOMO model is the same. It's just that it has included one extra feature or extra detail, that is effort adjustment factor, which we calculated based on the various attribute and their cost value. This is how you can calculate, and the values of AI, BI, CI, DI, these constants for each of the type of project which we can have had been listed in this table. So like you studied in basic COCOMO, similarly for intermediate COCOMO, you will have these three categories and you can use the respective formula with the proper coefficient. Okay. And the last type of model is detailed COCOMO model. Detailed COCOMO model includes, see, in basic, we had just the formula of effort and time. In intermediate, we had effort and time and one more factor that was EAF. And in detailed, they have even extra information which uses various effort multipliers for each cost driver. So now for the each cost driver which we had in intermediate, for that they have even more information, that is effort multiplier. Okay, and the whole software is differentiated into multiple modules. Then we apply COCOMO. So it does the modularity thing. It will decompose or divide into modules and then apply COCOMO and then combine them back. So that way it works, and this whole process is defined in these six phases, that is planning and requirement, system structure, complete structure, module code and test, integration and test, and cost constructive model. So in this way it works. You need not to get into much detail. You need to just clarify basic and intermediate COCOMO for your understanding. Because the experiment which you need to do here is applying basic and intermediate. So now you will understand this numerical better way. Okay. Here you need to find the project type. So study the details and you will get to know that whether it is in which of the category it is belonging. Similarly, size I have told you how to calculate. Then initial effort estimation you can calculate. Adjust effort estimation using the formula. Then schedule is the time and minimum size of the team I have told you. This is easy if you have proper understanding of the COCOMO model. Now, are there any doubts? Are there any doubts or anything you want to ask? Okay, no reply will be considered, no doubts. Now I'm taking attendance if you don't have any doubt.